Welcome back, ladies and gentlemen. We're looking at this week's problem of the week for grade 5-6 from the Center of Education of Mathematics and Computing once again. The question that we have this week is the Sony PlayStation is the best-selling video game console of all time. Annual sales data are displayed in the second column of the table below for the years 2000 to 2011. And as you can see in the chart here, they've given us our data. The first question says, round each year's sales to the nearest million and enter your answers into the table. Using the rounded numbers, approximately how many PS2s were sold from 2000 to 2011. Plot these sales on a broken line graph. And then the fourth question is, why is a broken line graph a good choice to display this data? And that's the question I really want to focus on for this week. Because if you were to go to our grade 5-6 students and ask them to name the graphs that we have, they can generally do that. They will tell you, first of all, that we have, for example, a pictograph, where we simply have our data displayed in that fashion. They will say that we have our broken line graphs, as it was referring to, where we simply have our dots. And we will see our trend accordingly. They will name bar graphs. And in this particular case, I'm going to throw you for a little bit of a loop and come from the sideways rather than the traditional up and down. And then finally we have our circle graphs. What you will see though is if you ask them why you picked this particular graph, that question becomes a little more problematic. And what we need to understand is each one deals with different sets of data. If the purpose of our graph is to understand trends and patterns, that's where we're going to use our broken line graph. We want to see if it's increasing, decreasing, remaining the same. If we want to do a comparison of data though, where one versus the other, that's where we're going to use our pictograph versus our bar graph. The difference between those two though tends to be in the range of our data. So if the range of our data is less than 10, we tend to use our pictograph. Whereas if the range of our data is greater than 10, we're going to use our bar graph. Finally, however, our circle graph is actually the one that I prefer the most because I find it the easiest to use. However, it does require an understanding of percentages and fractions. And so that's why it tends to be used last in our grade 5-6 classes, because those are concepts that we don't have the same level of comfort with as we do with the others. If you understand, however, though, how to create those fractions and do the comparisons within the circle graph, they actually become pretty basic to use. If we wanted to show, for example, data that was in the 50 percentile, we're simply going to use a line of symmetry. If we wanted to show in thirds or 33% of a data, this is where we're going to use what I call the big Y. If we want to show something in terms of 25% or a quarter, we're going to use our cross with perpendicular lines. And finally, if we wanted to show 1/5, this is where we use our star, what I call the star. And you're going to have to forgive my artistry because it's not always the greatest. But it's something, I'm just going to correct that one a little bit. It's going to be something along those lines. Any fraction after this is actually simply having them. If I wanted, for example, 1/6, I'm simply going to have the 1/3 after I create it. My 1/8, I'm going to have my 1/4. My 1/9 is actually a Y within the Y. The neat thing about circle graphs, though, is they also lend themselves to other areas. For example, this makes it very obvious. 3/6 is the same as 1/2 if I wanted a visual for equivalent fractions. Thank you very much, folks. That concludes our presentation for this week on graphing.